Last video in pre-calc, we are going to end it with the inventor of calculus, or at least the co-inventor of calculus, and that is Sir Isaac Newton. And so Newton's law of cooling says the temperature T of a heated object at a given time T can be modeled by the following function, where C is the constant temperature of the surrounding medium. So notice here we have two C's, we'll have to plug that value into both of those. Your T naught is the initial amount of temperature at a heated object, which is in parentheses here, and then K is a negative constant. So because we're talking about things cooling, it's going to always be a decay or a decreasing value there. So here's our example. A pizza baked at 450 degrees Fahrenheit is removed from the oven and is placed in a room that is a constant 70 degrees Fahrenheit. After 5 minutes, the pizza is at 300. So part A, using Newton's law of cooling to find a model for a temperature of pizza T after T minutes. We're going to round K to 4 decimals. So let's figure out what all of these things represent. We have 450, and that's going to represent the initial temperature of that heated object. So this is our T naught. It is removed from the oven and placed in a room at a constant 70 degrees Fahrenheit. C is the constant temperature of the surrounding medium. So here is my C. After 5 minutes, there is T. The pizza is now at 300. So there is my T. So let's plug in all of our values here. The only one we don't have is K, and so we will find our K. So T equals, that's 300, equals C, which is 70, plus T naught of 450, minus C, which is still 70, E to the K, and then my time is 5. So let's solve this for K. I'm going to do two things at once here. First, I'm going to subtract this 70 over to get 230. And then I'm going to subtract these. 450 minus 70 gives me 380. And then K times 5 is 5K. Okay, so I did two things in one. We subtracted 70 over, and we combined right here to get that 380. So now we're starting kind of where we were on uninhabited growth and decay models. First thing I need to do is divide this over so I can isolate that exponential. So let's just clear that, 230 divided by 380 gives me a decimal. I do not want to round until the very end. So I'm going to change that to a fraction, and we get 23 over 38. Basically, we're just dividing everything by 10 there. 23 over 38 equals E to the 5K. So let's rewrite that. Base to the other side of the equals will give me the natural log of 23 over 38 equals 5K. And then last I'm going to do is divide that 5 over. So I'm running out of room a little bit here. Now let's squeeze it in. So we'll get K equals dividing by 5. So we're going to get the natural log of 23 over 38 all divided by 5. I want to round to 4 decimal places. So let's get our decimal equivalent right here. So natural log 23 divided by 38 divided by 5. And to 4 decimal places, we'll go negative 0.1004. Okay, so we have our K. So what is my formula then? Okay, when I have my formula, I'm not going to know either of these T's here, but I should know everything else. So my formula will be T equals, this isn't going to change, 70 plus, when I combined these, we got 380. I now know my K is at negative 0.1004 and then T. So here is my formula or my model right here. And we got that by doing 450 minus 70 from what was right here in parentheses. Okay, so now part B wants to know what was the temperature of the pizza after 10 minutes. So let's plug in a 10 right here. So we've got T equals 70 plus 380 e to the negative 0.1004 times 10. Round to the nearest degree, so we'll go to the nearest whole number. And we're about 209 degrees Fahrenheit. And then how much time should elapse before you start eating the pizza if you want the temperature to be 120 degrees Fahrenheit? So there is my T. So in this formula here, plug in 120 here, and we're solving for this T here. So I've got 120 equals 70 plus 380 e to the negative 0.1004 T. So to solve for this T, first we need to isolate the exponential. This E right here is my only exponential portion. So first I need to subtract over 70. And now divide that 380 over. Okay, I can't use a decimal there, so I will convert to a fraction. So we're just dividing by 10 again. And now convert that to an exponential, or sorry, to a log. So right now we have an exponential with a base E. So when I go base to the other side of the equals, that's again natural log. And that's going to equal my exponent. And then divide to get T by itself. So we're going to get T equals the natural log of 5 over 38 divided by negative 0.1004. And that's going to give me what? It doesn't tell me how to round. I'm going to just go ahead and round to the nearest whole minute, and that's about 20 minutes. One thing you also can do, if you don't want to convert this to a decimal, let me show you real quick. We divide that 50, we divide 50 by 380. Okay, we need to keep this number in mind here. So you could write maybe right here 0.1316. And then we have the natural log of 0.1316, the natural log of 0.1316. And then we need to come back up here. So I could do the natural log and come up here and highlight this answer here, divided by that number there, and we get the same answer that we did right here. So you can also just kind of go up and highlight and use that entire decimal. If you have stuck with me and you have watched all of my lecture videos, specifically to my online students, thank you for taking the time to watch all of these lecture videos. Not that it's your problem or to make you feel guilty, but they do take a very long time. So I hope you liked them and I hope you got something out of them and you were able to learn the material through these note handouts and these lecture videos. And any of my on campus, like it was a pleasure having you guys. So just thank you and I'm wishing you guys all the best.